Here's a project where we measured, this is out in Minnesota, in the middle of this totally flat soybean field, and we studied an isolated turbine there by putting monitors in the four cardinal directions at various distances of 1,000 feet, 1,500, 2,000 feet, and we measured for 19 days continuously under all different wind conditions and so on. So here's just a randomly selected measurement. This is the frequency content of the sound. And here's the very low frequencies, 6, 8, 10 hertz, up to super high frequencies, 20,000 hertz, and the amplitude of it. So here's a measurement. It's just a 10-minute sample of this turbine in operation. It happened to be 48 dBA, 74 dBc. C weighting is essentially a measure of low frequency content in sound. And it's used most commonly for gas turbines and mechanical sources that generate huge amounts of low frequency noise. Now, here's the same measurement, 1,000 feet, the blue line. This green was taken at the same time 3 miles away from the project in an identical soybean field. And see, the level of low frequency noise in the background, where there's no turbine at all, is just as high. It's 73 dBc out there and 43 dBA. So it's a 30 differential between the A and C. Now, I've seen that 20 differential bandied about as a criteria, but you're going to exceed that just with the background common. And now this, I'm adding one more line on here. This black is the actual level of self-noise, or the false signal noise. This is just what the wind blowing through the microphone does. And we know it because we were wondering why the sound level tracked the wind speed so close. And we were wondering whether it was this effect that was driving the level. So we tested a bunch of wind screens in a wind tunnel in Germany, where it just blows air through here at known velocities, but there's no noise in the airflow. These are massive silencers. So we put a number of different wind screens in there and blew air at different velocities over them, just to see what this measurement error was all about, quantify it. And this is the wind screen that did the best in the test, and this is the one we use in all the field work we do. It's a 7-inch diameter windscreen. But even the 7-inch doesn't keep out the low frequency distortion. And by the way, the A-weighted level is not affected by that, because this false signal is down in the low end of the frequency spectrum, and A-weighting is not sensitive to that at all. So even though there's distortion, the A-weighted level is almost not affected. And we can calculate it from the results of the wind tunnel testing. We know exactly how to adjust the A-weighted level if we need to, but the changes to correction is so small, it's not even worth doing. It's only the low frequency noise that's affected. Okay, here's another example. This happens to be over at Maple Ridge, everybody knows. Now here's 3 measurements that I took with the turbine on. There was a turbine 1,200 feet away from this particular position, and with the turbine off. And this measurement position was shielded from the wind. There was no distortion in this measurement. So it shows that there's no significant change in the low frequency noise, whether the turbine's on or off. It's pretty low. It's down in the 50s at these low frequencies. And then this dip right here, remember I told you ground absorption. Ground absorption is a very highly frequency dependent phenomenon. It always happens at 250 hertz. So here over 1,200 feet, even though this turbine's 80 meters up in the air over a 1,200 foot path, you're still seeing all the sound of it's getting eaten up in this part of the frequency spectrum. And so what you hear at 1,200 feet is noise in this area, this region of the frequency spectrum, which is about 500 hertz, which is kind of in the middle of the frequency spectrum. This is what you hear. Just put that in context. Here's the same measurements with the turbine on, with the turbine off, 1,200 feet. And you have a C-weighted level with the turbine on at 60 here, but 58 or so with it off. But this measurement I took last week when I was driving in my car at 60. And this is what happens in your car. I had a C-weighted level of about 95 in there. So these levels are pretty low. Well, obviously, the low frequency sound level out in the field, there's nothing, no turbines. Everybody knows that's not going to be high. There's not going to be any low frequency noise there. Now that kind of leads into this health effects thing. A lot of the health effects are predicated on the fact that there's a lot of low frequency noise, and low frequency noise is causing the health effects. But first of all, I don't think there is any low frequency noise, which we just saw. But anyway, this study was recently done by a bunch of doctors and PhDs to look into this issue. I'm not a doctor, but there's about 7 bullet points at the end of this study. And I'll just go through them quickly here. Nothing unique about turbine noise. There's a lot known about cellular health, and this knowledge provides no evidence that there's anything happening with wind turbines. It does not pose a risk of hearing loss or any other adverse health effect on humans. Low frequency noise, not a problem. Of course, human nature, people will be annoyed. If people can hear it at all, there's a possibility of annoyance. And that can't be helped. But annoyance is not a medical condition. And then here, the last one is major concern is its fluctuating nature. Like I talked about before, it goes up and down. It has depends on the wind and weather conditions. The noise is not steady. So that character to it is what a lot of people don't like, and understandably so. So general summary, we did the background study based on the near minimum L90. We based it on the wintertime conditions. We just ignored the summer results. We correlated the sound levels at ground level to the wind speed measured by the net mass up at the rotor elevation. So we're measuring what the turbines are doing, would be doing, compared to what the sound level is.
Why not spring or fall measurement?